Welcome to Get Your FRQ On. This question is from 2018. It's question 1, and it is calculator active. In the question stem, we have people arriving to a line for an escalator modeled by a rate function r of t, which happens to be piecewise, although it does end up being continuous. R of t is measured in people per second, and t is measured in seconds. And then we are also told that as people get on the escalator, they also exit the escalator or the line at a constant rate of 0.7 people per second. And we're given that there are 20 people in line at time t equals 0. In part A of this question, we are asked how many people enter the line during the time interval from 0 to 300 seconds. The number of people entering the line is given by the definite integral, the integral from 0 to 300 of r of t dt, which is the integral from 0 to 300 of 44 t over 100 cubed times 1 minus t over 300 to the 7th dt. Because this is a calculator active question, we're going to use our calculator to evaluate that integral. The integral from 0 to 300 of r of t dt is equal to 270. Therefore, we can conclude that on the interval from 0 to 300 seconds, 270 people entered the line. In part B of this question, we are told that on the interval from 0 to 300 seconds, there are always people in line. And then we are asked to calculate how many people are in line at t equals 300 seconds. The number of people in line at any given time must take into account the rate at which people enter the line, the rate at which people leave the line, and the number of people who are in line at time t equals 0. The number of people in the line at t equals 300 can be found using the definite integral 20 plus the integral from 0 to 300 of r of t minus 0.7 dt, which is equal to 80. Therefore, we can conclude that at time t equals 300, there are 80 people in line. In part C of this question, we are asked for t greater than 300, find the first time t that there are no people in line. For t greater than 300, the number of people in line will be 0 when the 80 people in the line at that time have all exited the line. This happens at a rate of 0.7 people per second. So we can find the time t at which this happens by solving the equation 0.7t equals 80, which implies that t is equal to 80 divided by 0.7. And because this is a calculator question, we can use our calculator to find a value for 80 divided by 0.7. Turns out it's 114.286. So taking into account the first 300 seconds, the first time there are no people in line for the escalator is t equals 300 plus the 114.286 we just found, which is t equals 414.286 seconds. In part D of this question, we are asked for values of t between 0 and 300. Find the value of t when the number of people in line is at a minimum. Give the number and justify. The number of people will be at a minimum either at an endpoint or some value of t between 0 and 300, such that the rate at which people enter the line is equal to the rate at which they leave the line. That is, r of t minus 0.7 should equal 0. R of t minus 0.7 equals 0 implies that r of t equals 0.7. And since this is a calculator active question, we can use a calculator to solve this equation. The two solutions we get are t equals 33.013 and 166.575. We are given that there are 20 people in line at t equals 0. And we found in an earlier part of this question that there are 80 people in line at t equals 300. Now we just have to figure out how many there are at 33.013 seconds and 166.575 seconds. 20 plus the integral from 0 to 33.013 r of t minus 0.7 dt is 3.803. And 20 plus the integral from 0 to 166.575 of r of t minus 0.7 dt is 158.070. So the number of people in line is minimum at t equals 33.013 when there are approximately 4 people in line. If you want more AP Calculus AB free response question solutions, make sure to like and subscribe to my YouTube channel, and you can even follow me on X at x.com/getyourfrqon.